in this video, we're looking at probability trees. So probability trees are a great diagram that can be used to calculate more complex multi-stage events. So as you can see here, we have a probability tree. It shows the probability of winning a competition. So there's obviously three matches, I would say. So here would be match 1, here would be match 2, here's match 3, or competition 1, competition 2, competition 3. So 0.2 chance of winning and 0.8 chance of losing. And it's the same throughout the whole way. So it's important to be able to know how to read these and use this tree to calculate your probabilities. So we're going to cover that here. So when you're finding the probability of an event, like a specific one such as win, loss, win, we're working along the branches. We're going from left to right. And you can see that in blue on the tree diagram above. We're going win, then we have a loss, then we have a win. That's the probability of win, loss, win over here. Let's say I wanted to do another one down here. This would be loss, win, loss. You're going along the branches, all right? So when I'm trying to find the probability of that win, loss, win one, all you're doing is multiplying the probabilities on each of the branches until you get to the end. So in our case, we're looking at the probability of win, loss, win. That's going to be 0.2 times 0.8 times 0.2, because those are the probabilities on the blue line. So up here, down here, and then back up here, all right? So you just chuck that in the calculator and you end up with 0.032. All right, so that's the probability of getting win, loss, win. Now, it's not just useful for finding a singular probability such as that. We can use this to find the probability of multiple events, such as, let's say, we're just looking for any time he wins twice, all right? So 2 wins. So if we go back up here, what I can do is I can write out all my outcomes. So win, 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 loss, win, loss, 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 win, win, loss, loss, win, loss, loss, loss. So the ones I'm actually focused on is any time where I have 2 W's. So there's 2 W's there, there's 2 W's there, and there's 2 W's there, okay? So those are the probabilities I'm dealing with. So if I go down here, if I'm trying to say and try to find the probability of 2 wins, I know that I'm trying to find the probability of that win, win, loss one, and I'm going to plus the probability of the win, loss, win, plus the probability of loss, win, win. All right. So if we're working across the tree, we're timesing. If we're working down the tree, we're adding. Okay, so what I mean down the tree is like we have 3 things over here. We have 1, 2, 3. We're working down the tree, all right? So when we're going down, we're adding. When we're going across, we're timesing, okay? So I need to add the probabilities of win, win, loss, win, loss, win, loss, win, win. So if I go down here, I've already calculated these, so it's going to be 0.032 plus 0.032 plus 0.032. And that makes sense because they're all the same in this case. So we end up with 0.096 chance of getting 2 wins. All right. So again, with these tree diagrams, when you're working across to find the probability of a singular thing, it's times in those branches. And when we're working down for multiple events, we're adding them. Okay. So here we have a certain breed of cat has a 35% chance of probability of producing a white kitten. Okay. So what I would do here is I would create your tree diagram. So what we do here is we have a singular branch. We either have a white kitten or a not white kitten. Then we go off again. We have a white, not white, white, not white. And then it splits off again, white, not white, 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 not white. Just make sure you have enough room because it's not white. Oh. Not white, okay? So if we were to find the probability that it produces at least one white kitten. At least one white kitten. We're essentially looking for any time a W shows up once. So W, 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 N, W, W, N, W, W. Not white, white, white. Then we have, oops, white, not white, not white. All right, so probability of at least producing one white kitten. So the trick here is instead of going and adding everything up, because we know this has a white, this has white, all of these have at least a white kitten, we're looking for the ones where it doesn't. That's just the bottom one. So I know over here this was 0.35, which means this is going to be 0.65, 0.65, 0.65. So the probability of at least one is going to be 1 take away the probability of no whites. Okay, no white kittens. So that's going to be 1 take away. So over here, if I go the probability of no W equals 0.65 times 0.65 times 0.65, which ends up being 0.274625. So over here, we're going to minus 0.274625. And that gets us 0.725375. So that is your probability of getting at least one white kitten.